Everyone, and welcome to lesson 22.1. Today's lesson is going to start on page 293 in your Springboard books. We are going to focus on talking about the cofunction identities. So going back to this lovely picture that we've been talking about since last semester, we know that as we have this first quadrant value of theta, we're at x comma y, aka cosine comma sine on our unit circle. We know it's the unit circle because of that radius of 1. Now, when we are here, we say again it's cosine theta comma sine theta. Well, as we start moving around, this is at the bottom of page 293, if we were talking about negative theta, it's kind of like when we were talking about this being quadrant 1, and then I called this quadrant negative 1. It's because we're moving backwards, we're going clockwise, so we know that we are moving negative theta degrees would mean that we are moving clockwise versus counterclockwise with theta. And here at this value in quadrant 4, or quadrant negative 1, we would still be at a positive cosine value because our x value is still to the right, but our y value is the negative value that it was in quadrant 1. We had to go down y. So really we're at cosine theta comma negative sine theta. So those same values that we were at in quadrant 1, just the sine value is negated. So sine of negative theta, again, is negative sine theta, what it was in quadrant 1. Cosine, however, is the same because cosine is still that same positive value in quadrant 1. So some of these cofunction identities, these are called the unit circle identities. This is something that you may want to have down either on your formula sheet or in a separate note sheet, talking about some of these identities moving forward. Now, moving on to page 294, again, we see that same figure again. And we want to think about, again, as we look at these different reference values around the unit circle, kind of what's happening then in quadrants 2 and quadrant 3. Now, over here, for again that same theta value, we now had to move to the left. So our cosine is now negative, but the sine, the y value, is the same as it was in quadrant 1 because we went negative x comma y here. Now this is what we would call 180 minus theta, or pi minus theta if we're in radians, is kind of our quadrant 2 values. Quadrant 3, on the other hand, we know is 180 plus theta, or pi plus theta since we're beyond 180 slash pi right here on our negative x-axis. Now down here, our cosine and our sine are both negative compared to what they were back in quadrant 1. It's the same numerical value, just negated for both of them because we went to the left x units and down y units, so they're negated. So again, if we're talking about the quadrant 3 values, that's where we're looking at the 180 plus theta. And we know that the sine in this quadrant is negative. We know that the cosine is also negative in quadrant 3. And we know that the tangent, since we're dividing a negative by a negative, is actually going to be positive. It'll be the exact same as it was in quadrant 1, since tangent is positive in quadrant 1, and it's positive in quadrant 3. Now that being said, 180 minus theta, we said, represents quadrant 2. And in quadrant 2, 180 minus theta, the sine value was positive, so it's the same as quadrant 1. Cosine, however, is negative in that quadrant. And finally, tangent, since we're dividing a positive by a negative, sine divided by cosine is going to overall be negative because tangent is negative in quadrants 2 and quadrant 4. Okay. Now, speaking of quadrant 4, on this next piece, then, they want us to talk about 360 plus theta and 360 minus theta. So we know that that's going to be talking about our 360 minus theta, or 2 pi minus theta, is when we talk about quadrant 4 or -1. Again, we kind of talked of it that way. And then 360 plus theta is actually kind of going back to quadrant 1 because here was 360. And if you're adding another theta to it, you're actually back at quadrant 1 if you're talking about 360 plus theta. So kind of what's happening there. Well, again, if you're back at quadrant 1 with 360 plus theta, it's the exact same values they were before. Sine is positive, cosine is positive, tangent's positive. Right? We're back in quadrant 1. It's coterminal, aka to that original value. Now in quadrant 4, however, like we talked about kind of with the negative theta, again, you're back here. The cosine is the same value, but the sine was negated because we went down y units. So in this case, our sine value is negative, but cosine is still the same value it was in the first quadrant. And our tangent's going to be negative because we divided the negative sine value by the positive cosine value. So this may seem like a lot of work to memorize all of these, or they have them down here. Again, all of the radian measures then is anywhere you saw 180, you're replacing it with a pi, and then the 360s are all being replaced with a 2 pi. So again, they have all those different cofunctions that we just wrote down, but now for radians as well. So a lot of times I don't like to think about writing all of these different cofunctions down as much as I like to think about this picture and think about what quadrant am I in, and is sine or cosine or tangent or even the reciprocal functions, what value would they be there, positive or negative? So I really recommend having this picture drawn in as well to help you think about where are things occurring and what their values are at. And again, pi versus 180 and 360 versus 2 pi are the only difference between our radians and our degrees. So part 6 on the top of page 295 talks about if cosine of theta equals A and sine of theta equals B, what would be happening for each of these, okay? So I like to think about this again if we're looking at part A. If cosine is A and sine is B, it's almost like in quadrant 1, we're saying, okay, here's theta, we're at A comma B, right? A comma B or X comma Y, because cosine is A, sine is B. So at negative theta, that again is this value here, this negative theta, we just moved clockwise. It's again the same cosine value, but a different flipped sine value for B. So our sine would be the negative of B of what it was in quadrant 1. Cosine of 360 plus theta, we said, was back actually at quadrant 1. So the cosine is going to be exact same since we're back in quadrant 1. Think coterminal to theta. So all I did was add 360. 360 minus theta, again, is back here in quadrant 4. Again, think negative theta value. The sign there is negative, so negative B would be our answer. 180 plus theta, well, 180 plus theta is quadrant 3. And we know that both sine and cosine are negative here, right? Negative A, negative B. So the sine would be negated from what it was in quadrant 1. Cosine of 180 minus theta, well, 180 minus theta is quadrant 2. And in quadrant 2, our cosine is negative compared to what it was in quadrant 1. So that's A. And then last but not least, tangent in quadrant 3, 180 plus theta, we know is negative B divided by negative A, sine over cosine, which our negatives cancel, and we're just left with B over A. Okay, again, what quadrant are we in is kind of the game of the day. Now this last piece here then, we have with number 7, talking about one last piece of information, and this is using these 90-degree angles. And again, we want to go back to thinking about, if I asked you for sine of theta, go back to look at opposite over hypotenuse, we have x comma y, we know that sine is our y value over our r value. And cosine is our x value over our r value because we're looking for adjacent over hypotenuse. Now, what if I asked you for 90 minus theta, however? Well, 90 minus theta is this angle right here. This is 90 minus theta because this is our 90-degree angle. We subtracted theta away. So what if I flip-flopped this right triangle around so that this is still the hypotenuse, officially here, but now we have y and x this way and that way, right? So if we look at this as the reference angle, now my opposite is over here. Still, this is the hypotenuse. Here is my adjacent. So when we're looking for this angle as the reference point, the cosine is actually going to be y over r because it's the adjacent over the hypotenuse. And for sine, with now that this is the opposite for this angle, it's x over r. So it's a very interesting cofunction that it's switched up from what it normally is for us because we're looking at the complementary angle to theta. So again, we know that sine of theta equals cosine of 90 minus theta, and cosine theta is equal to sine of 90 minus theta. Now, again, you may not remember this from geometry land, but we actually talked about these in springboard geometry back in the day. Because again, if you think about it, if you have opposite adjacent hypotenuse, the cosine of theta is adjacent over hypotenuse. So let's call this side x, this side y. So, and then this side r. So y over r, where the sine of, let's call this alpha, the sine of alpha is opposite over hypotenuse, which is still y over r. So it all depends on, are you looking at this acute angle as your reference angle or this acute angle as your reference angle, because that will change which one is cosine and which one is sine. Okay. So again, definitely I would have these written down. So if we look here through this, when we talk about then our cofunction identities, this one might be something you want to write down because this is the one that's most easily forgotten. Now, this does apply for tangent and cotangent as well, and then cosecant and secant as well. And any of these 90s reminder can be replaced with a pi over 2. And then we also have officially that vocabulary word of cofunction and what exactly it is, and it's just an identity between two cofunctions would be the cofunction identity. All right, last groups of examples here. Let's look down at numbers 11 and 12. 9 and 10 were kind of covered on that last slide with writing those down, those identities. But we have here cosine being equal to 2 over 3. What would the expression have to be? And I really recommend here drawing yourself a picture that represents this. We have theta, we have our right triangle, and if we know cosine, we know adjacent over hypotenuse. So we know the adjacent side to theta is 2, the hypotenuse is 3, and by using some Pythagorean theorem, we know that our missing side is 9 minus 4, or the square root of 5. So now that we have this information, we can kind of solve the rest of these. We know that the cofunction identity of 90 minus theta or pi over 2 minus theta for sine means it's going to equal the cosine of theta that we know is 2/3. Right, we talked about that special identity on this last page that sine and cosine are going to share the cofunction identity there. Now, again, we want to think about what quadrant am I in. If I have pi plus theta, that's a quadrant 3 value. And I know cosine is negative in quadrant 3, so I'm going to take the original cosine and just negate it, because in quadrant 3, it would be negated. Same idea with the sine. I'm going to take the original sine from this problem, which is opposite over hypotenuse, and I know that negative theta means I'm in quadrant -1 or quadrant 4. So that means the sine is negative in that quadrant, since we would have to go down. Another example here is using pi over 6, and it says that the sine is 1/2. So again, I would recommend drawing in a picture. So we have opposite over hypotenuse, and again, using Pythagorean theorem, we find this remaining side to be the square root of 3. So the cosine of pi over 3 then is cosine of pi over 3. This is actually the same thing as looking at the cofunction, because the two of these together are complementary. So the cosine of pi over 3 is actually going to be the same thing as the sine of pi over 6, because again, it's the same idea as saying, the sine of pi over 2 minus this value, right, which is the pi over 6. Now, 13 pi over 6, we know is really back in quadrant 1. It's like we went around the circle a little bit more than once, so it's going to be the same value. It's the coterminal. So this is also 1/2. And then cosecant of pi over 6 is the reciprocal function here. So we would take our fraction and flip it, so it would just be 2. All right, last but not least, last examples we have are talking here. Now notice here 63 and 27 are the complements of each other. So going back to our cofunction identity, we know that these values, sine of 63 is equal to the cosine of its complement. So cosine of 27 is also going to be x, since that's what 63 equaled. Now cosine, again, of -27 would be the exact same as it was as +27, since in quadrant 4 or quadrant -1, cosine is still positive, so it would also be x. And then last but not least, sine of 63, this is the reference angle of doing 180 plus theta, so quadrant 3. And we know that sine is negative of what it would be originally in that value. And honestly, if you type all these in your calculator in degrees, you would see that you would get that same value for A and B, and then the negated value for part C. Okay. So we will work more with these in class. Thanks for watching, and definitely make sure you have your formula sheet updated.